All right, you guys, so I'm going to explain how to do problems 1 through 4 from lesson 14, which is our lesson on percent error. So it says a student estimated that it would take 3 hours to write a book report, but it actually took her 5 hours, and we want to find the percent error. So we're going to set up our table, and we are comparing hours to percent. Well, when we're looking at the problem, we always know that when it says actual, then that's the real total. So our 5 hours is going to be what our 100% is. She estimated it'd take 3 hours, so we need to figure out how much she was off by. Well, 5 minus 3 means that she was off by 2 hours. So her error was 2 hours. So we're eventually going to have to find her error of 2 hours as a percent. If you don't know how to jump straight from 5 to 2, remember that we've always said that you can always, of course, change it to 1 because 1 multiplies into everything. So I'm going to divide by 5, and what I do to one side, I do to the other side. 100 divided by 5 is 20%, and now I need to get to 2, so I multiply by 2, do the same thing to the other side, and so I get 40%. So our answer to this question is her percent error is 40%. Hopefully that one was pretty straightforward. Let's look at number 2. Number 2 says a radar gun measured the speed of a baseball at 103 miles per hour. If the baseball was actually going 102.8 miles per hour, what was the percent error in this measurement? So again, we're going to set up our table. And we're comparing the speed of the baseball to the percent. And so again, we're going to start with the actual is our total. So 102.8 is our 100%. And we need to find then what was her percent error. Well, what was the radar gun's percent error? Well, it measured the ball going at 103 miles per hour, but the ball only actually went 102.8, so you can do that math. Well, 103 minus 102.8 leaves us just with 2 tenths. So it was only 2 tenths of a mile per hour off. So we're eventually going to have to get to that error of 2 tenths. Well, I again don't know how to make this jump right away, so we always know that we can change it to 1. To do that, I'm going to have to divide by 102.8, and so I'm going to have to do that to the other side. I can take my calculator. 100 divided by 102.8 equals. All right, so we have this run-on answer. I'm going to keep it in my calculator so that I don't lose this and I don't round midway through the problem. So I know that my final step is going to be to multiply by 0.2 by 2 tenths. So I'm going to do the same thing to this side. I'm going to multiply by 2 tenths, and I get 0.1945, and it keeps going on and on and on. Well, I've been asking you to round to the hundredths place. So we're going to say then the percent error in this measurement and 4 rounds down, so that means it's just going to be 0.19 or 1900ths of a percent. Okay, and you can see this was very close, so the percent error is very small. It was only 2 tenths of a mile per hour off. All right, let's look at number 3. It took 48 minutes to drive downtown. An app such as Google Maps or Waze or something like that estimated, so this is an estimation, that it would be less than that. If the error was 20%, so the error is 20%, we're trying to figure out then what did the app estimate. All right, so again, we're going to set up our table, and we're comparing minutes to percents. Again, we know our actual time was 48 minutes, so that's our 100%. Okay, before we've been comparing hours and speeds and finding the errors there. Now instead it gives us the error in terms of a percent. And it tells us it was 20% off and that it estimated it would be less than that. So that means it's 20% less. Well, if we're starting with 100 and subtracting 20%, that means we're left with 80%. So I'm going to put 80 on the percent side. If you don't know how to make that jump, you can either change it to 1, or even easier in this problem would be to change it to 10. Divide by 10. Do the same thing to the other side. Remember, dividing by 10 is the same as moving your decimal 1 time, so this becomes 4.8. Then, to get from 10 to 80, I have to multiply by 8. Going to do the same thing to the other side, multiply by 8. 4.8 times 8 gives me 38.4. Remember, we're not talking about percent now, we're talking about minutes. So the app's estimate was 38.4 minutes. And that makes sense because it actually took 40 minutes and the app estimated it would be less. So check to make sure that your answer makes sense. All right, final one. Problem 4. A farmer estimated that there were 25 gallons of water left in the tank. If this is an underestimate by 16%, how much water was actually in the tank? So this time we're trying to find out our actually. Actually means we're trying to find out our 100%. Right now we have an underestimate by 16%. So that means I underestimated, so I'm taking away 16%. Well, 100 minus 16 leaves us with 84. So that means that this 25 gallons right now, I'm comparing gallons to percents, that this 25 gallons that he estimated would be in the tank was that underestimate by 16%. So that was only actually 84%. And I need to find how much was actually in the tank, so I need to find 100%. Well, again, I don't know how to make that jump right away, so I can jump to 1%. So I'm going to divide by 84 on this side, and I'm going to divide by 84 on the other side. Okay, I have 25 divided by 84, and I get this run-on number, 0.29761. Now to get to 100%, I need to multiply by 100. Multiply by 100. Going to do the same thing to the other side. Remember, multiplying by 100 is the same thing as moving your decimal twice. So you get 29 point, and we've been rounding to the hundredths place, so we want to round to here. Well, 1 rounds down, so we can just leave it as 76. So how much water was actually in the tank? I'm going to say there was about, and I'm saying about because we rounded, but there was about 29.76 gallons of water actually in the tank. I hope that helped clarify some things. Remember that if you miss something, you can always pause this video and rewind it. I'll see you tomorrow.